Okay, so we're on page 8. Okay, so stay with me for a few minutes here. We don't have too much to do today. Yes, I will honor Hayden's request and play the song one more time. All right, so on page 8. So actually, let me go back to yesterday. We're going to be talking a little bit about yesterday and mixing it with today. Yesterday, we did our best. If you still need to turn in that letter, make sure you get it to me. I'll take off 15% every day. But an 85 or a 75 or a 60 is still way better than a 0. So now we're going to go to page 8. It has an 8 on the bottom of it. It's partially cut off, but it does. So on page 8, we're going to. Okay, so thank you for defending me. These 3 bullets for continental drift. The main gist of continental drift is that the continents have moved. Alfred Wegener proposed this. We heard in the video in 1915. He's like, scientists, you better listen to me. I am pretty sure the continents have moved. Yeah. But they didn't listen. They laughed at him. They called him a crazy little man.
That's disrespectful.
It is.
I don't appreciate it.
No, I bet he didn't either. Huh?
You use one voice. Go.
I can't do this way. So we got these continents, and the continents are really just the crust and the mantle. They're broken up into pieces called plates, and they move around on the liquid layer of the earth. Hayden, so if you can't contain it, it's going to have to go to ice and you can watch the video. So again, we got this theory, and when the continents were all together, actually, I'll wait because I still see this writing. So when the continents were all together in one continent, they gave the continent a name, and what was it? Pangea, yeah. Oh yeah. So that was, we talked about that yesterday, but that much I'm pretty sure you guys have learned in your olden day classes, whether it was, somebody told me last period, 2nd grade. I don't think it was 2nd grade, but might have been a while ago. Oh, a few people are still writing up.
What language is meant to you?
Huh? I'm gonna go with English. I don't know. I mean, it might come from a different language, but right now I'm saying it and it's English. So Pangea, it was a supercontinent. It's when all the continents were together in one large landmass. Are you singing? And what evidence did from yesterday? What was the first piece of evidence that Alfred Wegener, when he saw this, he's like, dude.
Fossils.
First, you're right, we'll get to that. The first one was that the shapes match. And by shapes, I mean, you can put them back together like a puzzle. So here is a picture. Start off with Pangea here. A weird puzzle. I mean, it's not, definitely not candy canes and gingerbread houses like my daughter's doing right now. Her puzzle that she's putting together. Oh, sorry. So it starts off as Pangea, and over 225 million years, the continents have spread apart into their present day location. And the first piece of evidence that he saw, which a lot of you, this is the one that is obvious, South America and Africa, they fit right together. We're in one of the bubbles. Pick one bubble, right? Shape of coastlines. And then underneath it, continents fit together like a puzzle. The South America and Africa one, they're like the most obvious ones that most people notice right away. But as you'll see over here, they all fit together nicely. India fits right nice into this triangle made between Antarctica and Africa. Antarctica and Australia, there's like a notch out of Australia that fits together with that triangle section of Antarctica perfectly. Even Florida and the east coast of the United States hugs Africa perfectly. So they all nestle in really nice together. So that was his first piece of evidence. Then Hayden says fossils were his next piece of evidence. What about fossils? Just that there were fossils? The plants and animals watch. So what were you saying, Cynthia? Exactly. So it's the exact same fossil found in very different places. And let me tell you why that's weird. And this will kind of go back to last year a little bit. Last year, you learned that there are birds with different beaks on different islands, right? Why are there different birds on different islands with different beaks? They have to adapt. Whoa, even learned a vocab word. Who was your teacher last year? I will tell him so he can be proud of you. Mr. DC, I guess. Yes, I will make sure he knows that you remember that and he can give you a pat on the back that you remembered something from last year. And then there's that problem, but whatever. So should I tell him Braden or Dalton knew that? Oh my God. So I'll just, who are you? What should I call you? Dalton, okay. All right, that's just gonna mess with me. All right, anyway, Hayden is correct. We got these fossils. No, don't mess with me now. We got the fossil. Exact same species. Now you know from last year that when a species lives on a little separate island or on one continent, they have to adapt to where they live. If it's cold, they gotta adapt to the cold weather. Hot, they gotta adapt to the hot weather. They gotta adapt to the insects that are whatever that are there. So you would expect, just similar to the African elephant and the Asian elephant, you can tell they're cousins, but they're different because they had to adapt to their own environment. So because South America and Africa are spread apart, you wouldn't expect to see the same animal in both places, but it turns out we do. So here, I'm going to let you write this and then I'll talk because I know if I don't let you write, you're not going to listen. So go ahead and write real quick. Yeah, thank you. This goes in another bubble. So, it's a secret. I'll tell you in a little bit. Doesn't. All right, so this whole fossil thing. So going back, we already said that if places are separated by big oceans, the animals would have had to adapt and they would have been different. But what scientists have discovered is this guy, who I'm just going to call, because I don't know how to say that name, dog lizard. Kind of looks like a dog mixed with a lizard to me. So this dog lizard, they found in the exact same fossil, so the exact same species, no adaptations. They found that same fossil in both Africa and South America. Now, nowadays, South America and Africa are separated by a giant ocean. So this dog lizard would have had to adapt nowadays, so adapt to live where South America and where Africa are. So they wouldn't be exactly the same. So how could they possibly explain two of the exact same fossils?
Swim.
They swim. Does that dog lizard look like a good swimmer?
Yeah.
And I'm talking about across continents. You guys are, this is a long distance. We're not just talking about a day's swim here. No, it's,
It's the same thing.
but they wouldn't have been able to live where South America,
They got on a boat.
they got on a boat. Yeah, that's it. Or those continents used to be together in the same type of environment. Just like you said, they would have had to have the same kind of environment. And the only way for South America and Africa to have the same exact environment, for the same exact fossil to just, or animal to walk around in, they must have been together. Same with this leaf situation here. We definitely don't have the same kind of plants in South America, Africa, India, Australia, and Antarctica. A leaf off of a tree in
Yeah.
Antarctica?
Different trees on
Leaf, so, okay, so it's not just a leaf. It's a whole tree. They're representing it here with that leaf. But think about it. A leaf in Antarctica, a tree in Antarctica. How many? That's my question. Are there trees in Antarctica now?
Yeah, there's more trees down there.
No. Okay, so yeah, so if they're buried underneath the snow, they're not alive now. Where, well, how could they have trees in Antarctica? What were you gonna say, Jake? They used to be together, and not only did they be together, Antarctica must have been somewhere where trees were able to grow. Somewhere warmer. So Antarctica must have been warm enough to have trees on it. How could Antarctica have been somewhere warm enough? Well, it's drifted away from somewhere warmer. Yes, that's exactly what it means. Yeah, we will.
That would be okay.
In about another 225 million years, maybe. Because that's how long it took to go from one continent to where we are today. Well, I don't. That's how long it would take. I mean, I would assume. The next one was rocks. So rocks. We know how rocks form, right? What's one way rocks form?
That's going.
We got sediments getting put deposited, buried, and packed together. Perfect. You said metamorphic, got a lot of heat and pressure. What's the third way? Igneous rocks with lava, and lava usually comes out of volcanoes. So today, nowadays, when a volcano erupts, let's say on Hawaii, who's stuck with the lava then? Hawaii. Today, where Hawaii is located, when Hawaii erupts, the lava is only Hawaii's problem. We doesn't reach us. But what if a volcano erupted here? Where's the lava gonna go? It's gonna be all over Africa, but it's gonna probably sneak into South America. And that's exactly what has happened. They have found the exact same rocks that are the exact same age on two different continents. And the only way that that igneous rock could have spread at the exact same time to two different continents is that they were touching. Because nowadays, if a volcano erupted on Africa, it's never making it to South America. But if they were squished together like this, 100% that volcano could leak over there. So the volcano erupted when they were touching, and they've since moved apart. That's the only explanation. The other one is these rocks, mountain ranges matching up. And I actually have to go to a different slide. I should have just copied it over, but I didn't. I want to go to this one from, this is yesterday's slides. And I want to talk about this one. Okay, not that one, this one.
Not that one.
Okay, I'm not sure where the picture went that I wanted to talk about.
Yeah, we can turn to the right of one of those.
So not that one. Sorry, I didn't.
Brad probably is not familiar.
I just had it last period. Oh, well. Oh, there it is. Okay, no, it was slightly different on the other one, I think. Well, there's supposed to be, yeah, because there's supposed to be another one. Huh. I don't know what happened, but. So we have these mountain ranges here. We've got the Appalachian Mountains in America. We've got the British Isles and these Caledonian Mountains right here. What they have noticed is, yes, we got nice mountain ranges separated, but now I want you to picture, where does this section, if we were to put this puzzle back together, where does that section of North America fit in nicely? Yep, fits in. We got this little chunk right here, fits in perfectly there, and then the whole coast comes down here. If you can imagine bringing this section of North America over here, what do you notice about those mountains? They would match up, they'd make a perfect line right here. So these mountain ranges also match up perfectly. And the best way to explain that they got this nice straight line of mountains is, well, they must have been together at one point. The next slide, and you don't have to write this one yet. Oh, that explains that. I'm on the wrong, having a rough time here. That's me, yep. I must have just closed it out. No, this is the one I want right here. And there's the picture I wanted. That's it. There, now you don't have to imagine them squished together. Now you can see that North America fitting right in there. Those mountains make a perfect line together. This is straight from yesterday's slides. The last bubble, which I don't want you to write yet, because I'm just going to actually show the two that I think confuse people. This whole ice matching thing. We have not talked about glaciers yet this year. It's actually next chapter. But when glaciers come through, so a glacier is a ginormous chunk of ice. It kind of acts like a bulldozer when it's traveling around the continent. Just like a bulldozer will leave behind, you know how those bulldozers leave behind evidence of their tires, they're not tires, they're tracks. Or a big tractor will leave behind its tractor tire marks in the ground. Glaciers do the same thing, and they're called striations. When a glacier goes through, it actually is going to scratch the rocks below it. And those are called striations. They have found these striations in continents like Africa. How many glaciers are on Africa today, you think? None. Why? Africa's hot as bejesus, right? Really? Bejesus is a made-up word, sorry. Didn't you know that? Africa is hot, hot, hot. It's Africa hot. Yeah. The parts of Africa are desert. It's hot in Africa. There are not glaciers in Africa. Certainly not covering most of Africa like this. So they found evidence of glaciers on Africa and this whole coast of South America. Brazil and all those countries, not cold, not hot, too hot to have a glacier nowadays. India has glaciers, evidence of glaciers. India is not a cold place. Australia, still not a cold place. Yeah. It doesn't have the striations on it. So these ones are the ones with the arrows are representing the striations. I'm not sure why it's white here, but that's not a glacier. That's a good point. Anyway, so there's evidence of these glaciers on places that are now way too hot to have glaciers. Well, how could Africa have had a glacier on it then? Africa used to be together and it used to be a lot colder there. Same deal. This one, I think a lot of you struggled on this one if you even got to this one. The positions don't match. Meaning they found evidence of coal. Coal is made from, what did you guys read about coal? What's it made out of? What kind of plants? Compacted, but what kind of compacted plants? Dead ones, yeah. Tropical, it says right here. This is what you read yesterday, I think. Maybe it doesn't say it here. Yes, tropical plants. Coal was tropical plants. They found coal in Antarctica. What? Why do you say what? Right, so Antarctica doesn't have trees. How did it have tropical plants? Guys, tropical like jungle? So, because it had a jungle. Why is this mind blowing then? Because it doesn't today. Because it's covered in snow. So what must have been different in Antarctica? It used to be warmer. Now, how could a place be so warm that it could have a jungle on it?
Because it wasn't cold.
It was connected to something that where it wasn't cold and it had a jungle on it. Where must it have been then? I'm going to talk about that 1 second. So where must this continent have been? Near where you're saying Africa, but not where Africa was then, because Africa was somewhere cold. Remember, it had glaciers on. So Antarctica used to be somewhere warmer. Where is it warmer? The equator. So Africa or Australia, no, Antarctica used to be somewhere closer to the equator, so it was able to have a climate warm enough to have a jungle. I just want to talk about, Ted said something about global warming. When I say the temperatures are warmer, I'm not just talking about a few degrees like they're talking about in global warming, not even 10 degrees. Antarctica nowadays, where it is now, is negative 40 something. To have a jungle, you got to be well into the 80s and the 90s. So we're talking about a big difference. No, but still, that's not the same because that's only a few or just even a couple of degrees with global warming. We're talking it's completely changed its climate. Jungle to frozen completeness. So the last bullet you need, or the last bubble, is going to be this one. The last bubble is this climate change. When we find coal in Antarctica and glaciers in Australia and Africa, that means something big has changed. So this is all Alfred Wagner found. He found all of this stuff. The continents match. The fossils, the rocks, and the mountains match. And the climates don't make sense where they are now compared to what they used to be. But the scientists still laughed at him. They said, dude, you don't have, okay, this all makes perfect sense. But what you're missing, don't back up, we're not done. What you're missing is, how in the world could a continent move? Hayden said they were good swimmers. No, how could a continents right now, we don't just push them around.
They got floaties.
They got floaties. What scientists needed was proof to how they could move. And part of how they could move is right here in this lava lamp. I'd like you to turn over to page 9 and you will see a lava lamp. So in that lava lamp, I would like you to draw what's happening in that lava lamp. I want some movement. And if you can't see that lava lamp, here's an animated lava lamp for you. Draw what's happening with those blobs. And I know the lava lamp's still moving much slower than most lava lamps normally do. It just hasn't been on in a while. So you might need to look at that one to get the actual movement. They don't move that fast, but they normally don't move that slow either. Okay, you got it. Here, you can see. This one's still moving a little slower than normal. So what are you drawing? So don't say anything else. It's a secret. What are we drawing? Hey, we're not done yet, Ted. Ted, what'd you draw? What'd you draw? Yeah, what's the lava doing? Moving. How's it moving? So I got this piece of lava right here. What happens to it? It's just going up. And then we got lava up here. What happens to that lava? It falls back down. And the whole process starts over again. All right, so we're running out of time, but we're not done. Don't pack up. You still have one more step. For all of you who keep trying to tell me how it's working, write it right down. Every single one of you needs an explanation of how the lava lamp's working. If you have no idea, make up something. Little aliens in there with their floaties on. If you know, go ahead and write it. I would like some sort of explanation on those lines that then you can pack up. I want to know why. You tell me why it's going up and down. Even if you're making up a weird reason how it's going. Yeah. Tomorrow we'll talk about how this lava lamp is really working. Magic. Oh, Master D did it again. Guys, don't forget we have a quiz on ESRT page 10 tomorrow.
Since I wasn't here.
Yep. So
Do I still get points taken off?